Okay, so in this video, we are going to look at optimization, which is one of the main applications of calculus. So optimization is the process of finding maximums and minimums. So we know that max and mins occur at the critical points where f prime equals 0 or at the endpoint. And so the process of optimization is to maximize or minimize like revenue or profit or some type of function. And in order to do that, we are going to find the derivative, set the derivative equal to 0, and then solve for the variable, and then verify the values of max or min, either using the first or second derivative test. And so the first derivative test is finding the critical points and then making that number line and finding the max and mins that way. The second derivative test is finding the critical points and then plugging those values into the second derivative to see if it's positive or negative. So just as a reminder, we are going to do this a lot with cost, revenue, and profit. So just remember C of X is the cost of producing X units of the product. R of X is the revenue generated by selling X units of a product. The profit P of X is the revenue minus the cost. And if you have X units of a product are sold at a price P per unit, the total revenue is given by X times P, and P is called that demand equation. So if they give you the demand equation, you multiply it by X to get the revenue. So for our first example, we're going to look at maximizing profit. So it says find the maximum profit if P equals 55 minus 2X. So this is my demand function. And C, my cost, is 21X plus 98. So just as a reminder, profit is revenue minus cost. And revenue, because we need to find that, they didn't give it to me, is X times P, or X times the demand equation. So our revenue would be X times 55 minus 2X. So my revenue equation is 55X minus 2X squared. And because we want to maximize profit, we have to find our profit equation. So we found our revenue. To get our profit, then we're going to do our revenue, which is this 55X minus 2X squared. And we're going to subtract out the cost, which is 21X plus 98. So we're going to simplify this before trying to find the maximum. So we have 55X minus 2X squared, distribute your negative, and then combine our like terms. Okay, so we get negative 2X squared plus 34X minus 98, and that's my profit. And then if we want to maximize profit, what we always do is to find a max or min, we take the derivative and set it equal to 0. So this would be negative 4X plus 34. The max is going to occur at the critical number. So Cn for critical number. So to find that, we're going to set this equal to 0 and solve. Okay, that gives me 850. Okay, and this is, again, X is the number of units. And then it says find the maximum profit. So two things we're going to do. This is where it occurs. To find the maximum profit, we'd have to plug this in the profit function to find the profit. But before we do that, we do want to verify this is a max. So as long as we don't have endpoints, the easiest way to verify as max is to do the second derivative test. So for the second derivative test, what we do to figure out if it's a max or a min, we take and find the second derivative. So the second derivative of negative 4X plus 34 is negative 4. Okay, we plug in our critical point. Now in this case, because there's no X, it's just gonna be -4. I don't have anything to substitute in. And then we think about, okay, if it's negative, that means my profit function P is concave down, which means the critical point, which occurs where the derivative is 0, is going to be a max. Okay, and so this verifies that it's a max. Because if it wasn't a max and it was a min, then you would say there is no maximum profit. So we're verified. So now that we know that this is where the max occurs, we're going to find the profit at 850 because the question said find the maximum profit. So I actually want the profit. So I'm going to plug that into my profit function, this P of X here. And find that value. Okay, and so if you simplify that, you get $46.50. So that would be the maximum profit. Okay, so that's how you do optimization. I'll do a few more examples in other videos.